döküm sektörünün değerli temsilcileri, değerli meslektaşlarım, TÜDOKSAT Akademi'nin düzenlediği bir etkinlikte beraberiz. Yazın sıcaklarına hep birlikte göğüs germeye çalışıyoruz. Biz dökümhanelerde çalışanlar olarak bu sıcaklara alışığız. Ancak günlük yaşamda klimasız ortamlarda bazen zorlandığımız oluyor. Şimdi bu yılın seminer az, webinar çoklu programının sonlarına doğru yaklaşıyoruz. Çünkü Dünya Döküm Kongresi nedeniyle Eylül ve Ekim aylarında, Ağustos, Eylül, Ekim aylarında herhangi bir etkinlik planlamadık. Bütün ekip, bütün arkadaşlar e, Dünya Döküm Kongresi'ne odaklı çalışıyorlar. 18, 19, 20 tarihlerinde İstanbul'da, Bomonti'de 76. Dünya Döküm Kongresi düzenleniyor biliyorsunuz. TÜDOKSAT web sitesinden veya 76 WFC e, sitesinden faaliyetleri takip edin lütfen. Fikri Bey de şu anda 76wfc.com adresinin posta adresini yazdı. Şimdi o aktiviteye yönelik pek çok duyuru var, davetler var. En güzeli de 1500'e yakın davetlinin 4 davetli konuşmacı, diğer 14 oturumda da kendi davetli konuşmacıların olacağı yoğun bir programı birlikte göreceğiz. TÜDOKSAT Akademi faaliyetleri Kasım ayından sonra devam edecek duyurulduğu gibi. Bu kongrenin önemi TÜDOKSAT'ın kuruluşunun 50. yılı, Dünya Dökümcüler Organizasyonu'nun World Founder Organization 100. yılı. O nedenle önemli. Ne yapıp katılmanın yollarını bulun derim, öneririm. Zaten şu anda kayıtlı olan davetliler de 1000'in üzerinde. Şimdi webinarlara devam ediyoruz. Webinarlarda hem zamandan hem yol harcamalarından diyelim her şeyden tasarruf ederek ilgi duyduğumuz konuları dinliyoruz uzmanlarından. Bugünkü uzmanımız Foseco'dan Mr. Christoph Genzler. Kendisi uzun yıllardır boya konusunda Türkiye döküm sektörünün sorunlarında, uygulamalarında bilen bir kişi. O anlatacak. Türkçe yok. Türkçe ekran da değiştirilmedi bu kez. İngilizce. Herkesin İngilizceyi bu konuyu, mesleğiyle ilgili bu konuyu anlayabilecek düzeyde İngilizce bildiğini varsayıyoruz. Ee, Devamında soruları Türkçe veya İngilizce sorabilirsiniz. En alttaki sohbet kutucuğuna yazın lütfen. Bir de sunumun sonundaki anketimizi, memnuniyet anketini değerlendirmeyi unutmayın. Ee, Soruları cevaplandırmada Uğur Bey de bizimle birlikte olacak. Foseco Türkiye'den. Sunum kaydedilecek. Daha sonra TÜDOKSAT Akademi web sitesine paylaşılacak. Ama sunumun kendisini isterseniz o zaman Foseco Türkiye'deki ilgili arkadaşlara ulaşmanız gerekecek. Mutlaka bir temasınız vardır. Onlar da zaten bu sunumun sonunda en son sayfaya kendi iletişim bilgilerini koydular. Now, Mr. Gensler, it's your turn. I ask
Thank
you
you.
to introduce yourself and start presentation. Thank you.
Yes. Thank you, Sophie Bay. Yes, as you said, my name is Christoph Genzler. I'm the European product manager for coatings in the club of Foseco. And this position I'm holding for more than 35 years. So I've seen some coatings, seen some applications, seen some customers, seen a lot of things. And the theme for today, the headline, so to speak, is optimized, applied, and controlled coating, which is something that is always kind of, well, not so obvious, put it that way. You see my contact details. You will see them again at the very end of the presentation. The agenda for today is that I will introduce yourself into, say, three, although there are just two mentioned, three different features of coating products, and one more feature of a coating applied machine, basically, that helps to optimize the coating application as such. Now, I'm not sure, Safie, that you mentioned already the, say, housekeeping exercise, that you keep yourself muted. You can always ask questions during the presentation via the chat function. And at the very end, we will have an open discussion and open chat for whatever you would like to get to know in further detail. Semco coatings, what are they? They are a water-based product range within Foseco, which we actually reintroduced, I should rather say, back in 2023, and we won during GIFA the EcoMetals Award for that. What is the motivation behind that? Well, the motivation is definitely that molding core coatings influence foundry manufacturing cost dramatically. It is a known fact, but the influence on sustainability is not always that obvious. So listening to our customers and their demands, new features of coatings have been developed in response and are now widely appreciated by users, such as Semco CC for color changing coating on drying. So you will see how the coating can actually change color while it's drying. FD, Semco FD for faster drying coating, faster obviously, water-based coating drying. And the last feature, which I will just mention on the say on the side because it's pretty much standard by now, is the FF version, which means that we will not have a coating from Foseco supplied that releases formaldehyde while it is drying. What is the Semco coating range? In general, a new family of water-based coatings designed to overcome the shortcoming of traditional water-based solutions. These coatings help foundries to cut energy use, improve casting quality, and thus reduce operating costs and scope 2 and 3 carbon emissions. I'm coming to what that really means. With the development of biocides that do not release formaldehyde anymore, while we dry the coating, they also improve the overall health and safety in the foundry as a nice side effect. Scope 2 and 3, maybe they are not that much known in Turkey, but in Europe, it's really a big thing. Scope 2 and 3 CO2 emissions are indirect emissions that are common basically from your process or processes, I should rather say. That means your molding line, your drying furnace, your core shop, your, I don't know, cupola, whatever. As soon as that releases CO2, the consequence is that you will have a scope 2 or scope 3 emission level, which, you know, we sell in Europe at least, we sell certificates for. So it's quite a cost-intense feature. What can our coatings do? Our Semco coating range that I'm trying to introduce to you will help to minimize 50% of the drying time. In other words, it will 50% faster dry compared to conventional water-based coatings. It can save up to 20% energy on drying, and in terms of formaldehyde, it will reduce the formaldehyde emission by minimum 90%. Okay, let's go into more details. Fast drying coating. Well, fast drying coatings, of course, what does that mean? It's a water-based coating that is applied by dipping, brushing, flow coating whatsoever, and it will reduce the drying cycle time and, of course, then offer related productivity benefits. It will shorten or reduce the cost on drying and facilities that you need for drying. It will definitely reduce the energy consumption and also all the related costs with it. And it's just a safer and healthier foundry working environment as, for instance, hazardous solvents are removed from the process. Here, I hope you can see the video. It's a short video of, well, basically a case study on a windmill casting, actually a core that was made for windmills, and that was, yes, wind turbine casting house that was coated with a Semco FD. And please bear in mind now, let me just go back, that you see a just whitish surface, because I'm coming back to that. Yeah, so The challenge was, and still is, the customer wanted to improve core shop output to accelerate coating drying rate, and we had to do something. We had to basically invent, well, the faster drying coating, the faster drying water-based coating. In this case, it was designed for flow coating application, and with that feature of fast drying, we were enabling the customer to get 50% faster cores or molds out of his core shop or molding line, and in that case, improved his productivity. Yes. As a side effect, we significantly reduced the CO2 output, well, due to much less energy consumption in the drying process itself. Yes. Okay. Yes, Semco CC for color change coating. We will visualize very nicely the drying process. We have saving potential on the drying temperature and drying time. Actually, I'm coming to that. We can, with that feature, also furthermore reduce the CO2 emission and optimize energy consumption. It is a reversible color change. That means, for instance, in high humidity, say seasons in the year, say in autumn, for instance, when it's very humid, you will see that the color of the core changes back to the wet color. It also employs a process stability. It means that pretty much all operators can spot wet and dry core areas. Still wet or humid undercut pockets can be identified, which will then reduce the risk of facing gas defects. And okay, it's water-based coating, of course. That means it's not a harmful product at all. Here, once again, the case study, and then the case study. Yes. Well, okay. You see, coating within the color change visualizes the reduced energy cost and optimizes the drying process. Here we go. That's a pump housing from a German foundry called Baumgarten. And the coating that you see here is designed for dipping. Now, what you see already is a wet, so a core basically that's just coated, so in a wet condition as well as in a dry condition. The customer wanted really as a motivation to prevent defects caused by moisture and visualized drying, which was those days a nice request from the foundry or from the customer, which we, I must admit, haven't really thought about. So yes, as a side effect, we could optimize the drying process. You see, it's quite a nice flowing dip coating. And in wet condition, it's, I would say, purple, grayish purple, sort of. Now, this is what I mean. Here we go. So, still wet surface, dry surface, but as soon as the dry surface, this is just water spray basically, in the hand of my colleague. Once that water gets sprayed on the very surface, you see, here we go, that the color changes back to purple, to the original color, which is maybe, okay, in the very first place, not that important, but I will show you where it really makes sense. Here we go. Yeah, still wet surface. Talking about the, say, flow regime of the coating, how the coating is actually leveling. Yes. Oops. So, yes. So the coating itself showed quite nice benefits, such as optimized drying process, drying visualization, of the cores that are being cast. We had reduced the energy consumption by 20%, shortened the drying time, and increased, of course, the productivity. Now, the same feature applied for big molds or cores. Here, once again, that's a hop core for a windmill casting. You see the coating being applied. It's kind of pinkish, but as soon as you start the drying process, you can visualize very nicely how the drying progresses over that period, whatever the period is. Now, as a nice side feature coming from that development together with the Baumgart customer in Germany, we discovered that in particular, in areas that are not that obvious and that usually are overlooked by an operator, you can very nicely spot still wet patches on the core surface. In this region, in this area here, in a pocket sort of, you still see nicely how the coating still, after drying, after being in the drying oven, the coating is still wet, and of course risks were all fine?
Yeah, it's all.
Okay. Risks the gas defects and stuff like that. So from that perspective, just with the coating, with the color change coating, we were in a position to optimize the drying process. Having said that, what we also discovered is that while the coating is dried, the color change continues. In other words, the hotter the oven environment is, the darker the color becomes. So for instance, a normal dried core set at 120 is pretty yellow. The more put energy on drying into that furnace, the more that yellow changes to orange and furthermore develops into red, like you see here. So the more reddish core surface you see after drying, the greater the potential on energy saving is. And of course, still reducing drying time in the furnace. So here we go. You see that this feature, this color change feature, is now available with quite some coatings, some flow coatings, some dip coatings here for as an example for silent head castings. We also have it for polystyrene surfaces, such as in lost form or full mold processes, that the color changes from, I would say, pinkish, like red, pinkish, into is kind of a yellow. And still after drying, you see here very nicely the still wet patches. So you need to increase the drying time in that context. Yes, here we go. Yes, very quickly, Semco for FF for formaldehyde-free coating on drying. So basically, there was a big problem those days in early 23, in particular in Germany, where almost a big foundry was closing due to the formaldehyde release they had on the chimney of their drying facility. So we had to do something, and we had then developed a biocide basically inside the coating that does not release formaldehyde during the drying process anymore, and hence we reduced the released formaldehyde gases by about 90%. Yeah, I don't want to bother you with that so much. It was a new EU law. Yes, our solution was basically that we had, here we go, that we had reduced almost all formaldehyde emissions, and we had enabled the customer to comply with the latest EU regulation. Of course, for the operators, it was much better on the workspace as a working environment, and we could avoid the investment of costly rectification measures such as an afterburner and these kind of equipment things. Yes, so for you, I would like to remember, or make sure that you remember that all these Semco coating ranges can be tailored to your customer demands. So regardless of the application, whether it's flow, dip, spray, brush, whatsoever, we can tailor make all these different features into your coating that is designed for you. And of course, also bundle, say, fast drying with color change or just color change or just fast drying. That is then dependent on the demand by the individual customer. Having said that, I told you at the beginning, I would also like to introduce you to something that is really required to optimize the coating application. Nowadays, well, coating is more or less a, say, cost-related feature into the casting manufacturing process. To get the best and biggest benefit out of a coating, that is always then, well, a gamble, so to speak, whether or not your operators are fully skilled and, say, experienced enough to optimize the application. From our perspective, to apply a coating in an optimized way, you need kind of an automation to control, to adjust, and maybe also to prepare the coating that is coming into your facility, into your plant. In that context, we have designed, as you might know, the so-called ICU. The ICU is standing for a intelligent coating unit, and that is automizing the coating application. This automation will help the coating to prevent many surface and subsurface casting defects like veining, penetration, burn-on, internal particulates, metallurgical issues, erosions, and pinholes, because at the end of the day, you all know that once the coating is not properly applied, it can create problems itself. It can create runs and drips, brush marks, a lot of different cracks on the, say, corners. It can generate foaming, scabbing, poor adhesion, yes, definitely sedimentation, and blistering and all these type of defects. And that is why we introduced now the ICU that helps to automate layer thickness measurement, basically. The layer thickness measurement is usually and ideally done by using a layer thickness gauge that helps to determine the dry layer thickness. In that context, a too thin applied coating layer makes the coating not really working, not really effective. Too thick and the material is wasted, plus the risk of dimensional issues, scabbing, excessive runs and drips. So a wet layer thickness and the related dry layer thickness is a very good proxy, is a very good, say, measurement for the dry layer that is ultimately important. Now, normally, as you know, in your core shop, on your molding line, you apply a bombe or a flow cup kind of measurement to determine parameters of the coating. These parameters are then viscosity or bombe density, if you want, kind of, which gives you an idea, and just an idea, about the layer thickness at the end that you apply. Both methods are open to operator interpretation, which is in itself quite a risk. It is down to the measurement technique. You can, drop the bombe stick from that height or from that height. You can wait till the coating is in rest to measure bombe, or you can measure it when the coating is mixed. In both cases, you will have different values, although the coating is the same. Yes, and yes, we have local standards in terms of the flow cup viscosity, like DIN cups, Ford cups, ISO cups, and so forth. And in order to remove all that, say, confusion, I think the best way is still to use density as the ultimate coating adjustment measure. I will show you why. Just imagine that in your process you have a specification of the coating, either viscosity or Bohme, in this case Bohme is of 28 plus minus 1, or Bohme or viscosity of 15.5, which is already quite accurate, plus minus 0.5. In both cases, in that specification, you will achieve a wet layer thickness that has a difference of about 70 microns. Now, some of you might say, hey, 70 microns is not really that important and thick, but these 70 microns will determine whether your casting gets out as a good casting or might see some issues, some problems. Because, there we go, viscosity and Bohme are only aids to estimate layer thickness. Because at the end of the day, if you compare that to the density measure, you see that, I hope you see that, density perfectly correlates with a dry layer thickness. Now, this difference between wet and dry layer is defined for the individual coating. So say an automotive coating, as an example, would shrink like this, and coating for steel, as an example, or a coating for heavy iron castings would likely shrink not that much, but it's a typical shrinkage pattern of the wet to the dry layer thickness. So once we can measure density, once again, we have a direct correlation to the dry layer applied. And this is exactly what we want. We want to know how accurate and how consistent the dry layer thickness is. The correlation is kind of logic, because at the end of the day, you apply solids, and the solids are then determining the density of the applied coating layer. So the direct density correlates wet and dry coating very, very accurate. Now, I'd like to introduce you to the working principle of the ICU, the coating automation, basically. So to make sure that you understand our thinking behind that process, behind that machine. Yes, well, okay, the motivation, once again, the continuous increasing demand for foundries to demonstrate improving consistency and reproducibility still drives the motivation to automate coating, preparation, and control to a very high degree. Yes, we have introduced in 2011 already the concept of coating automation. Since then, the ICU has grown into the best in class and most robust industrial standard measure for coating consistency and control, and it has gone beyond the pure equipment solution and has become a frequently requested concept, very important to understand, concept adaptation for coating automation. So I'm going to show you now the working principle, the idea behind the ICU itself, some options, and maybe if we still have some time at the end, the applied concept. Now, the working principle is a little bit down to physics, and it's basically down to this equation, and how this equation develops is shown in that quick short video sequence.
Hi guys, today I want to talk to you about density and pressure. So what is density? Well, density is the ratio of mass to volume, and here we've got a...
Excuse me, Ur, can you hear me? Can you hear the
yes, this
voice?
sound is coming. It's
Okay.
clearly
Yes.
coming.
Okay, thank you.
equation to calculate density And density, with the symbol rho, is measured in kilograms per meters cubed. And to find out what density is, what the value of density is, well, we take the mass of an object in kilograms and divide it by the volume of the object in meters cubed. So what about pressure? Well, pressure is the ratio of force to area. So pressure measured in pascals or newtons per meter squared is equal to the force divided by the area in meters squared. The relationship between pressure and depth. So for a given liquid, pressure is directly proportional to the depth or the height of the liquid.
Not sure that this is so obvious, but let me repeat that. For a given liquid, the pressure is directly proportional to the depth or height of the liquid. In other words, regardless how deep in a dip tank, in a coating container, wherever you go, you have always the same pressure to height proportion. Okay?
So pressure equals rho GH, and I'm going to show you where this equation comes from. Well, if we've got pressure and height, so pressure in a liquid and the height at the bottom there, well, the gradient of this graph, which is pressure divided by height, is actually gravitational acceleration times by the density rho of the liquid. So the further down we go, the greater the pressure.
Obviously. But the further down we go, correspondingly the equation changes and the density will remain the same, calculated down to the same value, okay?
And if I've got a liquid with a higher density, they'll also have a greater pressure.
Yeah.
Okay, so pressure equals rho GH. Where does that equation come from? Well, firstly, you think of a cube with a weight or a force acting down at the bottom there. And our cube of our liquid has got dimensions L. So our cube, it's got a height of L, the width, and the length all of L. So we know pressure equals force divided by area. And in this case, the force is equal to mg. We also know that the density is equal to the mass divided by the volume. So rearranging that, we get the density times the volume is equal to the mass. And put this all in our equation at the very beginning. So we get pressure equals rho v times by g divided by a. And we know a is equal to L squared and v is equal to L cubed. So pressure equals rho L cubed g divided by L squared. Well, we can simplify this as rho Lg. And well, what's L? Well, it can be the height of the liquid.
Yeah.
So we get pressure equals rho GH.
Simple as that. So at the end of the day, the pressure is proportional to the density, the gravitational acceleration, and the height of the liquid. And this all means basically that in the ICU, where we use multiple pressure sensors, we can check densities in different levels. Now, the biggest advantage that we can employ through this kind of arrangement is that we measure density 1, density 2, density 3, and in case these are not the same, meaning that the coating has a problem in terms of sedimentation, in terms of bacteria attack whatsoever, we would get an alarm and immediately either just start the mixing exercise or do some other impacts into the process. The ICU itself comes with a
Yes.
everything okay?
Please go on.
The sensor itself comes with a 10-year lasting warranty, so it's a very robust equipment, basically component. In this case, it would control the density and the measurement itself, so it's a self-satisfactory, if you want, kind of machine. It is monitoring the coating suspension stability. The side feature of these pressure sensors is that they are also coming with a temperature monitoring. So in other words, they are also equipped with a temperature sensor, not adjustment, but just a temperature sensor. And of course, you might see that already here. We have designed the blade differently in terms of being able to rotate at the lowest speed, but still with the highest momentum to have very little shear impact onto the coating. Yes, so in that context, the ICU introduced those days in 2011 have now well started to grow into a rather big family. In order to not confuse you too much, I'd like to introduce you to these 5 different features. The continuous ICU, which is pretty much sold everywhere globally, and then the latest requirements on the integrated feature, the ICU H, just reducing the ICU to basically to its heart, if you want, to the brain, and how we can introduce that heart into a coating holding tank directly. And the DMT is just a coating measuring tool, very simple to use, and maybe replacing Baume sticks or viscosity cups in the very future. The ICU continuous looks like this, and well, we have learned during the introduction phase those days that if we connect a lot of different end users, such as dip tanks or float guard station, to only one ICU, we had to stop the coating supply from the ICU to the end user when the coating was consumed. In other words, when we had to refill the volume in the holding tank. With the ICU continuous, we don't do that anymore. We can utilize the full capacity of the tank to supply the end user, float guard station, spray equipment, or dip tank, whatsoever, because we have removed the measurement from inside the tank into, oh, we can see that here, into that measuring pipe. So there's always a 24/7 continuous, safe circulation of the coating inside the tank through that measuring pipe, and the coating gets adjusted just by measuring inside the pipe here. But this enables us to supply the end user continuously, which is very important to do. And I think with other machines out there, not possible. It's just possible with the ICU. Yes, on top of that, of course, there are still features, available options such as a spillage containment tank underneath the device, the coating inlet into the tank, guided by the steering shaft, just to reduce splashes. Sensor cleaning nozzles. Oops, excuse me. Sensor cleaning nozzles, 3 instead of just 2 sensors. We have Vega pressure sensors, wheeled membrane pumps, covers for the sensors, temperature monitoring for the coating in the tank. Sorry, that is a typo, should be in the tank. Quite interesting, an external steering motor socket like this and the timer for the mixer sitting on the container. So when you have a container supplied by us and the corresponding mixer sits on the container, the ICU can organize the mixing sequence onto that container. Of course, there's just a single or a double filter function, UV treatment for disinfecting of water. Quite important sometimes to reduce, especially in summer, bacterial attack. Yes, we have a built-in cleaning function and a built-in, if you want, verification or self-testing function that helps the ICU to always supply the correct readings. Yeah, just some pictures of the installations. Yes, in Satash, this is, I think, Ferro in Turkey. Yeah. Real-time view of the ICU itself. In this case, the ICU was connected to a dip tank. So you see we get the reading, how much the dip tank is filled, and different parameters of the ICU itself. It would give you the temperature of the coating inside the tank, the filling rate of the coating inside the tank, and the different speed of the mixer and which function is currently being used. So a pump or just a valve that opens and closes, plus a very simple press button exercise. So when the coating, for instance, has to be changed on the container, you just press a button, or the operator has to press a button, and that's it. The ICU does all the rest for him. Having said that, we have also learned during the introduction that the maintenance department has usually some, say, different requirements, different demands, and this is the maintenance screen that is now involved or embedded basically in the program to show that all the different components are running and in which case they had to be maintained or controlled and so forth. Yes. We were talking about the ICU concept. The ICU-I, the integrated ICU, is one of these concept ideas where we basically inside the dip tank introduce just the two pressure sensors, have the ICU, say, brain, the intelligence, sitting on a side panel. And this is how it looks like. 2 installations in Germany for rather big dip tanks. You see here the overflow level sensor, and the coating is then automatically diluted, controlled, and adjusted inside the dip tank. You see here the container with the corresponding mixer on top. That is also controlled by the ICU, by the way. And from this tank, well, actually the tank has a volume of more than 3,000 cubic meter. We also attached a small flow coating hose, so in case smaller cores wanted to be or had to be flow coated, we could use this the flow coating hose here to just flow coat the core straight over the dip tank. The ICU heart is one of the latest responses that we can supply to customers that just want to have the density control. Now, this comes with a control box and 2 pressure sensors and some valves, and then it is directly connected, as you see basically in the integrated version, onto the process inside the dip tank. Here is the intelligence, and I think on the next slide, yeah, here we go. On the next slide, you see the pressure sensors being mounted on the dip. This is the dip tank, by the way. Yeah? This is this dip tank here. So just been built into that dip tank, connected with the brain, with the intelligence of the ICU, and that's how we can integrate the ICU features, the ICU functionality inside the dip tank. That's why we call it integrated. Some customers do not have the option to have big dip tanks or flood coat stations. In these cases, we can actually supply the ICU-HI, which means the heart, once again, the brain, is integrated directly into a sizable tank where we circulate the coating in and control, adjust, and send it to the end user. And in that context, have a very small and flexible way of measuring density in a very controlled way. Yes, last but not least, the DMT stands for density measurement tool, has now coming to, well, the third generation, if you want, very simple to use. You just stick basically these two pipes inside the coating, wait some seconds, and then you get the reading. So you would read density directly from the device, which is, I think, only available at Foseco. Nobody else, not even the paint or anybody else in the liquid industry, has this kind of feature to measure on site the density. I must admit, the machine or the device is not meant for continuous measurement. So it is meant to replace bombe sticks and flow cups for a control, for a spot-wise control, for one-shot control, basically, or measurement after the button is pressed. Yes, so it's very simple to use, and the size is, I would say, a little bit bigger than a mobile phone, maybe. It's also coming with a battery, so it's quite simple to use. Yes. Just to give you some ideas about the ICU functionality again, we have two different specifications, if you want, on the ICU that we can set ourselves in which way ever we want. We have the alarm spec, which of course in that case gives a 5.5% alarm spec. In this case, it is the normal control, inner spec sort of, in which the ICU operates continuously. And in this case, very early in the process, you saw how accurate the ICU actually measures at an offset of 0.04%. So that is so accurate that you cannot even think about measuring this accuracy with a bombe stick or with a flow cup. It's basically impossible for a human being to be that accurate. However, I must admit, during that period, still within the introduction, I would say the offset of 0.04% is really the limit, because the machine starts to just control, rather than, monitoring, applying and readjusting. It just controls itself basically to death. So that does not make sense. Well, nice to see, but actually is an overkill, if you want. Yes, then once again, early in the process, we had the opportunity to introduce a machine into one of our Swedish customers. In this case, it was, of course, Volvo, and you see the set point that was given and the individual measures or measurements done per day. A bottom limit of a 0.5 specification, the bottom limit and the top limit. So you see how nicely the ICU operates. Actually, what you see here, the zigzag, means that the ICU is refilling consumed coating. We would also see quite nicely that, sorry again, here we go, that in this period of, I don't know, maybe a Friday or something, the ICU was not really in use. I told you at the very beginning that the ICU also possesses this feature of monitoring temperature. And okay, that was in summertime in 2019 in Sweden. We see nicely how the coating temperature develops during a week. Yeah, so start that's always one day, so 24 hours basically. Yeah, the 8th, the 9th, and now the 10th. And you see how the more the week continues, the warmer the coating gets. It's not maybe that big deal in Sweden, because we're talking, 23 degrees or what? I'm very certain that in Turkey, this 23 degrees will be easily close to 30 degrees. And then we have a problem once again with the bacteria. So let me summarize then the key benefits of the ICU. It definitely helps to utilize the coating to the optimal degree. Excess consumption is avoided. the application, the layer thickness is maintained, meaning that you can optimize your drying because there's always the same drying speed of your course, and the same layer thickness means also that you have the same performance in terms of against the casting for on all the cores. The coating preparation, adjustment, and final application becomes a much greater consistency. The ICU works with the most accurate density measurement in the industry, measurement system in the industry. It's got a low maintenance level. It's got a very low noise level, very easy to access. It optimizes drying times, as I said, reducing energy and reducing the CO2 release. Very simple to use. 3 pressure sensors will test its functionality and supply sedimentation monitoring. We have a data logging that lasts for more than 1 year. Yes, okay. And yes, if needed, if requested, the access to the machine can be done via the internet. So regardless where you are, you can always watch and monitor what's going on the ICU in your molding line or in your core shop. Yes, it's got a great solid design, foundry proof basically. It's got an integrated mixer time and empty container alarm in case you need to convert the empty container to a new one. Yes, it minimizes coating waste. The ICU is already prepared for industry 4.0 standards. That means it can, if you want, talk to your other equipment in the core shop on the molding line. And thank you, gentlemen, or ladies and gentlemen. And
Thank you. Thank you, Christoph. That was quite informative, and we have learned quite a lot new developments. Actually, something is new, something not. The new one is I see some traces of artificial intelligence. You did not
Okay.
mention, but is it true that intelligent coating unit is compiling too much info, and operator has got less to do?
Well, I would rather say the operator's life should or will become easier.
Okay.
Yeah.
Okay.
So instead of taking all the responsibility into his hands and temperature dependence, and maybe he's not in the best shape on Monday morning or Friday evening or afternoon, the ICU will still do the same job. So from that perspective, it is just more consistent and will give the operator, well, a more relaxed time.
Okay, I am expecting questions from my colleagues. They started to write down. During that time, we can go on chatting. So it seems that it is almost impossible to cancel, to dismiss the operators in this operation.
I'm not sure that what you mean, that we can stop the operator impact?
Yes.
Yes, we can. I mean, on this case, let me just, you still see my screen, yeah?
Yes, we see. Which
In
one?
this case,
Yes.
we actually could release 1.5 operators from the line just because of the ICU did the job of controlling, preparing, and measuring the coating in use on that line at Volvo. Yes, so that is possible for sure. And this operator can do then, I don't know, other jobs. Yes.
Other activities. Okay. So the first question is coming from Mehmet Saadettin Turhan.
So if you sorry. Okay, Christoph, the question is about if there any process to reduce to prevent the reduction in strength after coating and drying processes? Is there any progress? He's mentioning, first of all, he thanks to you for the presentation. He's asking if there is a process to prevent any reduction of strength after coating and drying progresses. To get your some advices and opinion for these cases.
Well, to be honest, if the coating is applied, diluted and prepared always in the same way, it should have always the same kind of strength levels or surface, if I correctly understand what you mean, surface strength levels. Is that what you mean?
I mean, coating process, yeah, the coating processes and let's say the curing, they are reducing the strength. So he is asking how to reduce this strength level differences, if there any process or something to apply. Is there any way that fast drying coating can support us in these cases?
Yes. Well, the way is definitely an ICU kind of feature to have, a very consistent layer thickness application, which means that also the drying process, the drying time, the energy consumed is always the same and optimized. What we have also learned, remember in the very beginning, I told you something about the SEMCO CCs, SEMCO color change.
Yes.
Now, in order to optimize, let me see if I find that slide quickly. In order to optimize the drying process for the customer, in this case here, to optimize the drying process for a cylinder head core package, big one for the customer, we implemented the color change at the very beginning of the process, of the project, I should rather say. That enabled the customer to optimize the drying speed to a degree that he could reduce, what was it? I think 15, roughly, maybe 13, but in that range, 13 to 15 minutes per cycle time. Can you imagine how many more cores that means and how the productivity improved in that case? So this is an option to say, okay, we would like to optimize our drying process by a color change feature at the very beginning. Then once that is done, we can remove the color change again, and then you still run on a ideally optimized drying performance.
Let me explain it also in Turkish way. It's
Yes,
a
of
bit
course.
easier. I mean, herkese merhabalar. Şimdi aslında soru güzel bir soru. Şimdi birçok kişi tarafından da bakıldığı zaman bu operasyonlar için, yani mukavemetin işte en optimum değerleri elde edebilmek için işte kurutmayı nasıl yapalım, boyama işlemini nasıl yapalım gibi problemleri çok karşılaşıyoruz. Tabii ki günümüzde enerjinin maliyetinin artması, işçiliğin maliyetinin artması bu tarz şeyleri mühendislik gereğince optimize etme zorunluluğu kılıyor. İşte aslında burada fast drying dediğimiz boyamızda da buna bir destek olabilse de burada aslında Christoph'un da söylediği gibi en uygun olanı bizim color changing dediğimiz renk değiştiren bu boya aslında anlatmaya çalıştığımız. Birçok dökümhanede bazı işte her ne kadar siz fırın içi sıcaklıklarınızı 110 dereceler, 150 dereceler, 160 dereceler nasıl ayarladıysanız ayarlayın. Fırınınızdaki kaçaklar veya işte fırınınızın boyutu, hacmi vesairesiyle aslında tam o değerleri yakalayamıyorsunuz. Burada asıl olan sizin burada fırının derecesinin kaç olduğundan ziyade maçanın veya işte parçanın orada kuruyup kurumadığı, nemini atıp atmadığı. Color changing dediğimiz bu renk değiştiren boyalar aslında bunun için amaçlanıyor. Bunları tabii ki dünyanın birçok yerinde sürekli kullanan gibi genel olarak şöyle bu tarz boyalarla şunu amaçlıyorlar. İşte fırınların içerisinde boyamayı yaptıktan sonra acaba işte 15 dakika sonra kuruma başladı mı? Fırının içerisinde bunu takip edebiliyorsunuz. Belki 30 dakika boyunca gereksiz yere tutup mukavemeti düşürüyorsunuz. Ama aslında sizin 20. dakikada o şartlar altında boyanız çoktan kurudu ve nemini attı. Veya işte tersine de oluyor aynı şekilde. Bazı yerlerde işte bakıyorsunuz boyanız işte nemli bir ortamda çalışıyor. Tabii kuruduktan sonra tekrardan bu boyayı koyduğunuzda eğer nem kapmaya başladığında tekrar farklı bir renge geçiyor. Böylece aslında o boyanın nemli olup olmadığını, o parçanın nemli olup olmadığını, döküme gidip gitmemeniz gerektiğini görüyorsunuz. Dolayısıyla karşılıklı aslında burada bir optimizasyon süreci var. Sürekli kullanmak maddi açıdan farklı sıkıntılar da doğurabilir, biraz pahalıya geçebilir ama biz bunu her zaman özellikle dönemsel geçişlerde bu tarz boyaların kullanımını önemsiyoruz. Bu sizin mukavemet seviyelerinizi optimize edip gereksiz yere işte fırın uygulamaları vesaireleri engelleyecektir. Aslında tam da her ne kadar sunumla alakalı olmadığını düşünseniz de aslında tam da sunumla bir alakalı bir soru Mehmet Bey. Ben teşekkür ediyorum. Umarım cevap verebilmişizdir.
Uğur Bey'e açıklamalar için teşekkür ederiz. Arkadaşlar karşımızda bir uzman var. Boya konusunda e, yıllar yılı hem döküm sektörünü bilen hem de Türkiye üretim koşullarını bilen bir uzman. Dolayısıyla sizden sorular bekliyoruz. Yoksa bizim sohbete devam için elbette sorularımız var. E, Sunumu daha sonra videosunu paylaşacağız sizinle, sunumu değil de.
Sunumu talep edenler için Seyfi Bey günün sonunda bize ulaşırsalar işte
Evet.
paylaşabileceğimiz yerlerle ilgili yapabileceğimiz yani birkaç müşteri dosyası şeklinde dediğimiz yani sizlere sunabileceğimiz şekilde gönderebiliriz. Bu konuda bir problem yok. Ama Seyfi Bey'e katılıyorum. Christoph bizim için bizim bu sektördeki üstadlarımızdan birisidir ve yani hani aklınıza takılan bizler de destek oluruz ama Christoph buradayken sormak istediğiniz konuyla alakalı veya işte bağlantılı olduğunu düşündüğünüz sorulara cevap vermekten memnuniyet duyarız.
So you have defined your unit as intelligent coating unit. Intelligence comes from the not from the measurement capabilities, but
Oh, yes, it
from
does.
the uh, topic like density you are measuring.
Exactly.
That
Yes.
it comes from this, isn't it?
Correctly. Yes, that's correct. I mean, we have, as I said, we are quite dinosaurs in the coating industry, sort of. And we have found that, you know, with the application of Boehme or viscosity, we have always deficiencies on the application. And if the application does not work properly, usually the customer complains, hey, your coating is not working. So we had to find something that kind of automizes the application and actually gives us the ideal situation to have almost a readout that corresponds to the dry layer thickness, because that is definitely what we would like to control, the dry layer thickness, yeah? And with the density, and we discovered that, we have basically a direct correlation to the dry layer thickness. So yes, you're right. Intelligence comes from the way of applying, well, density in this case, yes.
Okay, related with this topic, there's a question asking, what if these measurement of density could solve our core expansion defects?
Yes. Oh, definitely it can.
How?
Let's assume that you found the optimum layer thickness in your process, and you want to make sure that this optimum layer thickness, regardless where that is always applied. In that case, the density helps you very nicely to always have that optimized layer thickness to avoid veining issues, burn on, scabbing. Scabbing is another thing, you know, is in wintertime, as an example, you have a rather thick coating. So Boehme as well as viscosity will increase, which will, just because of temperature influence, which will mean that in wintertime, usually the coating is over diluted, so too thin, and you would apply less layer, although, once again, on the back, although the specification is still met, because Boehme and viscosity in wintertime, as I said, is pretty much temperature dependent. And if that is met, you will increase that difference from not just 70, but say to 120 or even 150 microns. And that definitely has a big influence into the dry layer thickness, i.e. into the core or coating performance. One more thing to just a very final statement. The
Please.
brightest and most expensive coating in the world does not work if it is wrongly applied. Okay, so
Okay.
yeah.
Okay. The question owner, Abdullah Turan, is indicating that, especially on the cold box course, is there a difference? Is there a difficult alternative application for cold box, hot box, or warm box course?
Mhm.
The expansion scabbing problem have been met on cold box course.
Yeah.
And your application, your explanation is valid for cold box course as well, isn't it?
Full box for all core binder systems that you, even molding binder systems that you can imagine. Yes. Once the optimum layer thickness is found, it is quite simple to put that in the ICU to make sure the ICU controls automatically adjusts and measures the density to its optimum.
Thank
So
you.
you have always this optimum layer thickness. Okay.
Thank you. Uğur Bey, Mehmet Bey size soruyor. Bir cihaz
Evet,
soruyor.
teşekkürler. Çok açıklayıcı olduğu sınırda bu ne sıkıştı ölçümleri boya kalınlığı için tahmin konu. Yani boya kalınlığı verilmesi bayağı için sınıfta bulunan cihazlar dışında bir yöntem var mıdır? Bayağı için sınıfta bulunan cihazlar dışında.
Okay.
The question, Christoph, the question is if there is any other measurement techniques that you presented for density measurements, just for your information. The question, I mean, any other methods that we can measure for the densities rather than you explain during the presentations?
You mean instead of the pressure sensors?
Yeah, exactly. Any other methods how to
Well,
measure?
there is a quite scientific method existing employing, I don't know, in Turkish, pygnometer. You have a cup that is defined of 100 milliliter. You put that on a balance and you just read from that 100 milliliter the density. But of course, this does not give you the chance to automate the measurement. With the pressure sensors, you can automate the measurement and get a reading, a continuous reading if you want, per second, per millisecond even, of the product in use.
Yeah. Bu yani pikrometre dediğimiz bir cihaz var. Hani onunla kullanılabilir. Yani çok fazla tabii ki bu. Ya boyanın şöyle önemli olan burada zaten bu tarz sistemlerin en güzel özellikleri. Şimdi tanklardan bahsediyoruz. Boya kullanıldıkça veya süreç geçtikçe, karıştırma yetersiz oldukça zaten neden hani burada bunu akıllı yapan sistem aslında neden buna yönlendiriyoruz? Tabii ki var ölçümleri. Pikrometrelerle bunu her türlü yapabilirsiniz ama olay şurada. Şimdi boya belli bir süre kullanılmadıkça özellikle zirkon bazlı boyalarımız olabilir. İşte daha yoğun boyalar. Bunların sedimente olma ihtimalleri yüksek. Bu tarz sistemler sizin veya daldırıp çıkardıkça boyanın kendisi aslında yukarıdan gidiyor. Biraz daha su kısmı veya alkol bazlıysa alkol kısmına gibi bu tarz şeyler kalabiliyor. Şimdi bu boyalarda alt, orta, üstten sistemlerde ölçümler yaptıkça sizin aslında karıştırmanızı da optimize ediyor. Sizin boyanızı da full optimize ediyor. Dolayısıyla her yerde aynı bir ölçüm almaya çalışılıyor. Yoksa aksi takdirde işte çok büyük maçalarda daldırdığınızda alt yüzeyin işte bunu çok karşılaşıyoruz. Bazı ICU'yu koruduğumuz yerlerde de işte yeterince ayarlamalar veya sonradan değiştirilen özelliklerde bazen alt, orta, üstte farklılıklar olabiliyor. İşte proses veya maça özelliğine bağlı olarak. Ama işte bu tarz sistemler hemen bunu anlık düzeltmelerle, örnek veriyorum sizin ortanız, altınız ve üstünüzün arasındaki deviyasyon biraz farklı olduğunda sisteme hemen boya veya su vererek aslında alt, üst, orta seviyesi eşitleniyor. Bu sebeple biz otomasyonu öneriyoruz aslında. Günümüz buna gitmek zorunda yavaş yavaş diye söyleyebilirim size. Ama kesinlikle biz Foseco ekibinden herhangi biri geldiğinde genelde BOME ile çok fazla konuşmayız. Genelde yoğunluk aslında bizim için kriterdir diyebilirim size.
Uğur Bey'e teşekkürler. Christoph, there's no more question. We thank you a lot and we hope to see you in October in Istanbul during
Yes,
the
we
World
do.
Founder Congress.
Thank you, Seyfi Bey. All the best.
Arkadaşlar hepinizin katıldığınız için çok teşekkür ederiz. Eminim yar sağlamışızdır hepimiz bu sunumdan. Daha detaylı sorular için Foseco Türkiye ekibi sizlerle temas halinde olacak. Sağlıkla kalın, iyi günler dilerim.
Teşekkürler. Thank you Christoph. Teşekkürler.
Thank you.
Thank you. Bye bye.
Goodbye. Bye-bye.
Bye bye.